So this is an astonishing equation. This is describing to you the process of photosynthesis, at least in terms of the reaction running from left to right. So photosynthesis would go from water plus carbon dioxide to a sugar, starch plus oxygen. The reverse, which is what I'm doing and you are doing sitting listening to this, or burning the stuff, respiration. We could not have respiring, oxygen-breathing, using animal life on this planet without the presence of the other kinds of life, photosynthesizing. This only developed after the development of the Earth at 4.567 billion years ago. The oldest evidence of life we have, photosynthetic life, is on the scale of the Earth's existence, not that long after. But let me just put the numbers up. We've got pretty good evidence that the Earth was first formed 4.567 billion giga years ago. The oldest rocks we have are in the order of 4 billion years. We've got rocks from our neighbor, the moon, which are older than that, which are very close to this. Oldest evidence of life we have is of the order of this, 3.8 billion years, in places like the Pilbara of northwest Australia. And it's algal. The kind of life evidence we have is in the form of stromatolites, the sort of things you can see growing right now in Shark Bay. But that's the oldest life we have. Now this was photosynthetic life, so early on the Earth was doing this, or at least the life on Earth was making oxygen and these sugars and starches. Initially, there wasn't a lot of oxygen in the Earth's atmosphere. The life had to be going for a long time, and one of the things that happens to oxygen, if you're not using it, is compounds like iron just love oxygen and making an iron oxide. And if you add water to that, that's a compound that you don't want around really quite often, certainly not in your car. It's rust. But there's so much iron in the basalts that make the surface of the Earth, at least on the ocean crust, that for a long time they will soak up all the oxygen that photosynthetic life has to offer. You just rust the Earth. Eventually, if you slow down the rate of the manufacture of ocean crust, if you do that, so that there's less amount of iron being produced per year, slow down the rusting rate, in other words, make a veneer of rust over the surface of the planet, you've now got the opportunity to start accumulating oxygen in the atmosphere. And many people recall this, the Great Oxidation Event. When did you first start seeing free oxygen appear in the Earth? And let's say it's of the order of 3 billion years, more or less. So the GOE, Great Oxidation Event. It wasn't in a day, it was over a long time. But this marked the period of time when free oxygen started appearing in the Earth's atmosphere. The Earth's atmosphere now is nowhere near what it was when we first started the Earth. It looked very different.